Bismillahirrahmanirrahim. Assalamu alaikum and good morning to my students. Uh, my students, finally we have reached to the end of the exercise and we are doing today the examination practice questions. And I told you that I'll be doing each and every question from this exercise because this is very important exercise and this is the précis of this whole chapter we have already done. In this chapter, we have covered some very important points, and that are numbers and prime numbers and integers and positive numbers and square numbers and even numbers, odd numbers, LCM, HCF, prime numbers and factors to the prime numbers, and lot of more things. Uh, and we are going to sum up all these things in this one exercise now. I've already left two exercises in between chapter number one, because from time to time I've already told you uh, the matter which was in those exercises. I already told you in my lectures. So I'll request you to please subscribe my channel, that's mathematic, and keep on sharing to your families and to your colleagues and to your friends. Uh, Let us start with the exercise now without wasting any more time. And this is examination practice question. Well, my dear students, we'll be doing examination practice questions, and the pattern of the exam style questions we are going to do it today now. The first question is, here is a set of numbers. Now I'll write the question number one now. Question number one. And it is, here's the set of numbers. I'm going to write only the set of number. And that is -4, -1, 0, -4, -1, 0, 3, 4, 6, 3, 4, 6, 9, 15, 16, 19, 20. 9, 15, 16, 19, and 20. And the bracket has been closed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, this is our question, and the things asked about these questions are, we have to find the natural numbers in part A. We have to find the natural number, all the natural numbers, all the natural numbers. And in the very first lecture, I told you about the natural numbers. So what are the natural numbers? The natural number starts from 1, not below 1. So you see that this, and this will be excluded from the natural numbers. And the natural number, the definition of the natural number was, it starts from 1 and it goes up to infinity. From 1 to infinity are all the whole numbers, from 1, all the whole numbers from 1 to infinity from 1 to infinity are the natural numbers. So what are the natural numbers? In our example are 3, 4, 6, 9, 15, 16, 19, and 20. So, end of part A. Part B, we have to find square numbers. Square numbers. Square numbers are those numbers which came into existence by multiplying two same numbers. Like 2 multiplied 2 is 4, 3 multiplied 3 is 9, 4 multiplied 4 is 16. So let us find 4 is first square number, 9 is second square number, and 16 is third square number. These are the only square numbers because it came into existence. Now it came into existence by multiplying 2 with itself is 2 multiplied 2 is 4. 6 is not the square number. 9 came into existence by multiplying 3 with itself is 3. 3 threes are 9 and that is 15 is not a square number. 16 came into existence by multiplying 4 to 4. 16. And but these are all the square numbers. Next, C. C is negative integers. Negative integers. So dear students, there are only two negative integers over here and these are minus 4 and minus 1. Prime numbers. So prime numbers, a very distinct property, bearing a very distinct property. Now, now these prime numbers are the numbers which are divisible by itself or with 1. So 3 is the prime number over here and 19. 3 and 19 are two prime numbers over here. Rest of all are not the prime numbers. 3 and 19. Let me write E over here. Multiples of 2. 0 minus 4 minus 1. Minus 4 minus 1 0. So multiples of 2 are 4, 6, 16 and 20. 4, 6, 16 and 20. So these are the multiples of 2 because 2 times 4, 2 3 times 6, 2 4 times 16 and 2 5 times 20. E. Now this is the last part and factors of 80. What are the factors of 80? The factors of 80 are 4, 16 and 20 because 4 times if I just find the factors of 80, what are the factors of 80 will become 80. Now 2 times 40, 2 times 20 and 2 times 10 and 2 times 5. Now these are the factors of. Now you see that we do have 4 over here. We have 4 over here Okay, we have 16 over here. 4, 4, 16, and we have 20 over here. Now this is 20. So the factors of 80 be 4, 16, and 20. So this was the end of the first question. Let us proceed to the next question, and that is question number 2. Question number 2, list all the factors of 12. We have to write the factor of 12. It is very simple again. Writing the factors of 12. Start from the lowest prime number, 2, 6 and 2, 3. Now these are the factors of 12. 2 times 2 times 3, and you know how we write it? F12. 2 times 2 is 4 and 4 times 3 is 12. Now these factors comprises of the prime numbers only. But I told you in my uh, lecture about factors that 1 is also the factor. 1 is also the factor, and the number which is given is also the factor. So you see that we have come up with 2 more factors, and there is one more factor, and that is 6. 2 times 3 is 6. So one factor is, first factor is 2, 1, second is 2, 3, 4 and 6 and 12. So these are the total factors which we can write for 12. But these are only the prime factors. 1, 2, 3, 4, 6 and 12. Now for 24, the same factors of 24. Let me do it with the tree method. When you are asked to do the factors, then I do it with the tree method. Now you see how many factors we are coming up with is 2, 6 and 2, 3. So we have come up with 1 and the factor itself, the number itself. 2 factors, 1 and 24, and first factor is 2, second is 3, third is 4, 2, 3 times 6, 8 and 12. So these are the total factors for 24, which I have found with this tree diagram. Question number 2, part C is, we have to find HCF, highest common factor of 12 and 24. Now we have already done. Now this was for F12 and this is for F24. So which is the highest common factor in between the two is 12. You see that there is only one factor which is the highest, and common in between the two, and that is 12. Question number 3 is find the HCF of 64 and HCF of 64 and 144. HCF of 64 and 144. I'll do for 64. 2, 3, 2, 16, 8, 4. So F64 becomes 2, and for 144, 2 sevens are 2, 3, 2, 6, 18, 2 F144, 4 twos and 1 3, 3 twos, 2 threes. So my dear students, what are the common factors in between 1, 2, 3, 4? These are the common factors. And 2 times 2, 4, 4 times 2, 8, 8 times 2 is 16. Now 16 is our required answer. HCF is 16. Question number 4. List the first 5 multiples of. Now first 5 multiples. First 5 multiples. And part A is 12. So we have to write the first 5 multiples of 12. So the first multiple be 12, 2 times 24, 3 times 36, 4 times 48, 5 times 60. Now these are the first 5 multiples of 12. B. 18. Similarly, 18 is the first multiple, 36 is the second multiple, and 54 is the third multiple. 72 and 90. 30. 30, 60, 90, 120 and 150. This is a simple table. You know what is the table? 1 times 2, 2 times 2, 4, 2 times 3, 6, 2 times 4, 8. Now this is a simple table. And for the last is 80. It is very simple. The numbers with 0 are very simple. You see 0 coming in each multiple. So 8 1 times is 8, 8 2 times is 16, 8 3 times is 24, 8 4 times is 32, and 8 5 times is 40. So these are the required multiples. Now question number 5. LCM, we have to find the LCM of 24 and 36. 24 and 36. The method will remain the same. 24, 2 times 12, 2 times 6, 2 times 3. And for 36, 2 times 18, 2 times 9, 3 times 3. So we'll write F24, F24, and that is 2 times 2 times 2 times 3. And F36 is 2 times 2 times 3 times 3. Now we'll pick up the common numbers from each of the factors. Now this is common, this is again common, and this is common. So write all the common for once. That will become 2 times 2 times 3, and all the leftovers 2 times and 3. Just multiply all these. 2 times 2 4, 4 times 3 4 times 3 12, 12 times 2 24, 24, 3 times is 72. Now 72 is our required answer. Question number 6. Prime numbers. We have to write prime numbers from 0 to 40. You know that 0 is not a prime number. 1 is not a prime number. So 2 is the first prime number, 3, 5, 7, 11, 13, 19, 23. Now dear students, prime number from 0 to 40 are, you know that 0 is not a prime number, 1 is not the prime number, 2 is, and the prime number starts from 2, and 2 is the only even number which is also a prime number. So 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, and less than 40 is one more, and that is 37. So these are the list of the prime numbers from 0 to 40. From 0 to 40. Question number 7. Now what does it say? Use a factor tree. Now we have to draw a factor tree for what? For 400. For 400 we have to draw a factor tree. Now factor tree, how we do it? We write 400 over here. Then we start with the lowest prime number, and that is 2. And now this 4 is also divisible by 2. So it becomes as 200. Now this stops over here, and we start from this end. Now again this 2 is divisible by 2, so it becomes 100. Again 250, again 225, and for the last it is 5 and 5. Now this is the whole T diagram for 400. You can also check it. 5 times 25, 50, 52 times 100, 102 times 200, and 202 times 400. Now, how to write this? The factors of 400. Now this 1, 2, 3, 4. Now 4 bases are same. So we write 2 raised to power 4. And these two powers are also same. So we 2 raised to power 4 and 5 raised to power 2. Now we have to, now this was part A and part B. Part B is asking us to express 180 with the division method. Now we have to use division method to express it into the prime factors. One 1080. Start with the lowest prime number, and that is 2. 5 times 4 and 0. 540. Again it can be divisible by 2. 2 4 times, 2 2 times, 2 7 times, and 0. 2 1, 2 3, 2 5. 5 3, 8 and 1, 9, 3. 3 4 are 12 and 3 5 are 15. 3 again. 3 1, 3 5. 3 3 again. 3 5 are 15. So these are the total factors, prime factors of 1080. So we write here in this linear form 1080 will become 1 2 3, 2 raised to power 3, 1 2 3, 3 raised to power 3 multiplied by 5. Well, dear students, in question number 7 part A, we have to find the factors of 400, and in part B we have to find the factors of 1080. But for we will keep them for our reference in for the next part, and that is part C. In part C we have to use this working, and we have to find, what we have to find is use your answer to find the LCM of 400 and 1080. Now we have to find the LCM of 1080 and 400. Now you know how we find the LCM. You see that we have uh, 3 uh, 2 raised to power 3 and 2 raised to power 4. That means we have 3 in commons. 3 2's are common between the two. Now we have to find the LCM of what? LCM of 400 and 1080 from the result we have already obtained. Now if I write this is as 4 2 and 5, I have just elaborated this. The 2 raised to power 4 means we have to write 4 times 2. 2 times 2 times 2 times 2 and 5 raised to power 2 means we have to write 5 two times. So I have written it 2 times 2 times 2 times 2 and 5 times 5 times. Now for this is again, when it is cube, we have to write it for 3 times, and similarly 3 for 3 times and 5. Now we have to find the common in betweens. Now you see, from here or from here you can see that 3 2's are common. 3 2's are common over here. You see that this is common with this is common with this is common with this. So we have 3 2's in common. So what we do is we write all the 3 2's which are common. Now this is common, and this is common. This is common with this is common with this is common with this. Now for 3, 3 is not common. Here 3 is not common and here 3 is not common. But 5 is common. 5 is common over here. 5 is common and 5 is common. So we write here 5. Now my students, you see that these are the factors which are common. Now I have to write which are the leftover factors. Now here we are left with 1 2 and 1 5. So write them 1 2 and 1 5. Okay. Now here we are left with all the 3 threes. So we have to write all the 3 threes. Okay. Now we have to just make them like this, raised to power. Now this 2, 1 2 3 and 4, 2 raised to power 4, and then 3 raised to power 3, and then 5 raised to power 2. 2 raised to power 4, 1 2 3 4, 3 raised to power cube 1 2 3, and 5 raised to power 2 1 2. Okay. So we have to write it in this form. So we have written it this in this form: 2 raised to power 4, 3 raised to power 3, and 5 raised to power 2. Now we will write what it will become. 2 2's are 4, 4 2's are 8, and 8 2's are 16. Now it will become 16, it will become 27, and it will become 25. Now what will be the answer? We have to use the calculator for this. 16 multiplied 27 multiplied 25 becomes as 10,800. Now it will become 10,800 is the answer. So this is the question number 7, part C, sub part 1, that is equal to 10,800, and it is the LCM of 400 and 1080. Now what we have to find it in the second part is HCF. Now HCF for same two numbers. So there is some similarity between LCM and HCF. You see that we have picked here common numbers and uncommons or leftover numbers. Now we have to select only or pick only the common numbers. So we have to, HCF is of the same number will become, now you see the common are this, this and this. So we have to pick all the three, 1 2 3. We leave this, we will pick this one also. This is 5, and we have to leave all the leftover numbers. Now we have to leave all the leftover numbers. Now this is leftover, this is leftover, this is leftover. So the only result will become 2 raised to power 3. That will become 2 raised to power 3 and 5. And this will become 8, 8 5s are 40, the answer. Now this was part 2, sub part 2 of question number 7, part C, sub part 2. So dear students, in question number 7, part C, sub part 2, we have to find the HCF of both the numbers, and that are 400 and 1080. So what we did here is that we have picked one each out of the common factors, and that are 2, 2 and 2, 2, 2 and 2, and 1 is 5 here, and rest of are the leftover numbers. Now this 5 is leftover, this 2 is leftover, and all the 3s are leftover over here. Now what we do, we don't use the leftover numbers. As you know that in HCF we don't use the leftover numbers, we only use the common numbers. So common factors are 2, 2, 2. We have written here 2, 2, 2, and 1 5 is common here, and we write here 1 5. So if we multiply all these together, the answer will be 40. Proceeding towards the next part of the same question, part 3. Question number 7, part C, sub part 3 is we have to find the square root of 400 now. Well, for the square root, what we do here, in the division method or the factorization method, let me do it in the division method for the first. Now we write here 400. As I told you, the divisor and the quotient be the same. Now you see that if I do it like this, no remainder is left, and 1 out of 2 zeros will be written over here. So the square root of 400 is 20. But if I do it in by the factorization method, start with 2, 200, 100, 50, 25, and 5. We have to pick 1 out of 2's because it is a square number. 2, 2 and 5. So what it will become? 2 multiplied 2, 4, and 4 multiplied 5 is 20. So this is our third answer. The number is the same now. Part 4, 1080. And the writer has asked that whether this number is a cube number or not. Now, and how will you find it? Now there is only one method to find it, that it is a cube or not, and that is we'll make its factors now. Now how we'll make its factor? Like in the previous one, as we did it for the 400, we will find its factors. With a vertical line, with a horizontal line, we start with the smallest prime number, and that is 2. Now 2, 5 times 10, 2 5 times 10, 2 4 times 8 and 0. Proceed as it is to 2 times to 7 times to 0, to 1 times to 3 times to 5 times. You see that now it is not divisible by 2, but it can be divisible by 3. So 3 4 times 12, 3 5 times. It is again divisible by 3. 3 1 times, 3 5 times. Again divisible by 3. 3 5 times, 15. So what we have to find that is this a number, a cube number or not? Now we have to make a pair of 3 factors now. 1 2 3, 1 2 3, and it is only 1. So what we do here, we can bring out 2 from here, we can bring out 3 from here, but we cannot bring 5 out of here because it is only one factor left over here. If and only if it was 5 5 5, then we had to bring then we would have brought 1 5 over here, like here 3 3 3, we brought 3 over here, 3 instead, 2 2 2 and 2 over here, 3 over here, but we cannot bring 5 over here because here the 5 is alone. Here the 5 is alone, and therefore the inference is that 1080 is not the cube number. So write we can write this answer somewhere over here. So we can write 2 power 3, 3 power 3, but this is, this is only 1 power. So we don't have to write anything over here. So we can pick 1 2 from here, 1 3 from here, but we cannot pick 5 from here. Therefore this number 1080 is not the cube number. So dear students, I think this session has been already prolonged, so we conclude our this session over here. We'll be discussing the next upcoming questions in our next session. So it's time to say goodbye to you and sign off from Mathsnatic. Plus, but please remember to subscribe my channel Mathsnatic and push the bell button as well. So it's time to say goodbye to you. Goodbye and Allah Hafiz.